So we were studying about conduction up till now, and last time we saw that if air is placed and stagnant air is placed between the two plates T1 and T2, so and since the medium is stationary, so energy will be transferred only by the diffusion or conduction heat transfer. And how means the particles which are near the hot surface will be having higher energy, and the particles which are having low energy will be near to the bottom surface, and there is no bulk motion of the fluid, and energy is being transferred only by the vibration of the molecules and collision of the molecules. The higher energy molecules will transfer their energy to the low energy molecules. So moving ahead, we have also seen that in solids how what is the mechanism of conduction. So let's write here. In solids, conduction is attributed to atomic activity. In the form of lattice vibration. That is three-dimensional structure of the solids, and molecule in the solids. The solids atoms are arranged in very tightly manner, so they cannot move from one location to another. So the only thing that they can is vibrate, and during vibration, so let's say this is hot side, this is cold side, and due to vibration, this atom 1 will transfer energy to atom 2, atom 2 will vibrate, atom 2 will transfer the energy to atom 3. So that's how energy is transferred in solids by conduction, the form of lattice vibration. So in electrical non-conductors, as we have seen here, electrical non-conductors or insulators, no free electrons are there, so energy is transferred only because of the lattice vibration. Okay, and no free electrons, and it is proved from the research that and movement of free electrons. It is shown from the research that effect of movement of free electron is much greater than the effect of lattice vibration. So that's why metal have high thermal conductivity as compared to insulators. So because in insulators there is no free electron, and lattice vibration contributes to only small amount of thermal conductivity in solids and conduction, so less conduction in insulators as compared to metals. So that is the reason insulations are uh, used to stop the heat transfer, like in steam pipes, in the power plants, and all, and also in refrigerators. So, moving ahead, now we know that conduction, how conduction is transferred, what is the mechanism. So, how can we quantify that conduction heat transfer? So, for that, we have to understand the Fourier's law. So, Fourier's law. Fourier's law states that the heat flux at any section is directly proportional to the temperature gradient, and when we remove the proportionality constant, it comes with some constant K, which is the transport property of the medium, known as thermal conductivity. It is in watt per meter Kelvin. Heat flux. So let's move it down. Heat flux. It is watt per meter square. The negative sign attributes that heat always flow in the direction of decreasing temperature gradient. So let's suppose there is a plane wall. Plane walls means that one dimension is way small than the other two dimensions. So let's say this is the thickness of the wall, and these are the length, this is the height. So length is very smaller than width and height. This is called plane wall. So let's say that different temperatures are maintained at the two surfaces, and some temperature gradient is there, so heat will flow from higher temperature to lower temperature. This is the heat flux that is we can calculate. And inside this plane wall, if there is no heat generation and steady state condition is there, let's for assuming no heat generation and steady state condition, then dt by dx will be constant and temperature profile will be linear between the 2 points inside the wall, like this. So we can write dt by dx as T2 minus T1 by L. And if we want to find the heat transfer in watts, just at any x, just multiply the heat flux into area, that is perpendicular direction in which heat flow occurs. For now, for our case, this is that area. Width into h. Let's now understand the convection heat transfer. So convection is comprises of two modes. So we can say two mechanisms are involved in convection heat transfer. So what are these two mechanisms? In addition to the random molecular motion, that is known as diffusion, energy is also transferred. This is one mechanism. Another mechanism is energy is also transferred by the bulk or macroscopic motion of the fluid. Bulk motion means large number of molecules are moving collectively as an aggregate. If such motion take place in the presence of a temperature gradient, it contributes to heat transfer. And in convection is good mode of heat transfer as compared to conduction. In various industries, we use convection to cool the electronic equipments like our laptops. So what happens in convection is, let's say this is a plate with a heated surface. And some undisturbed fluid is moving from here. So what happens according to fluid mechanics? Whenever fluid comes in contact with the surface, velocity boundary layer is formed. Okay, if that fluid is having different temperature than the heated than the surface,